Okay, here is our Trimester C final review. Miss Partial is going on a trip in her favorite rocket ship. She packed a suitcase that contains 7 shirts, 3 pairs of pants, and 2 pairs of shoes. How many different outfits can she wear, consisting of 1 shirt, 1 pair of pants, and 1 pair of shoes? So for these problems where we are taking one item from each category, they actually are quite simple. We just multiply together the 3 totals from the categories. So 7 times 3 times 2. And we should get 42. I'm going to double check. Yes. Question 2. Explain the difference between NPR and NCR. So P is for permutation, and that is used when order matters. C is for combination, and that is used when order does not matter. So an example of when order would or wouldn't matter, something like a race. How many ways can the runners finish first, second, third? How many ways can we vote for specifically president, vice president, secretary? Those are permutation type things. Combinations are when it's like how we're just randomly picking 3 volunteers from the class. You are choosing 2 members from the committee to be in charge. You're just randomly picking a couple people, but you don't care who you pick first and who you pick second. All right, question B. There are 10 candidates for a job. Exactly 3 will be hired. If all of the positions are the same, in how many ways can the jobs be filled? So if all the positions are the same, it doesn't matter what order you hire them in. They're all going to get the same job. So this would be a combination. So we have the total first, 10, C, and then 3 is how many we're picking. So reminder how to do this in the calculator. You start with the math button, and then you go over to probability, and then you should see your NCR. I will say, actually, you need to type the 10 first, and then do all this, and then the 3. So when we do this, C3, we get 120 different ways the jobs can be filled picking 3 candidates. There are 8 runners in the finals of a race. In how many ways can first, second, and third place be awarded? So now this one, order matters. This is an NPR problem. So 8P3. 8, 3. All right. 3, 3, 6. So there are 336 different ways the runners can finish. Find the probability of drawing a red, then green from a bag of 6 red, 9 green, and 5 blue with replacement and without replacements. So there's 2 questions here. So A, if we replace it, red, there are 6 out of 20 reds times then green, so 9 out of 20. So if we put it back, we still have 20. So 6 times 9 is 54 out of 400. Which you can leave exactly like that as a fraction. You can also write it as a decimal. You could also write it as a percent. Those are all acceptable. Question B, without replacement. So when we draw that red marble, the 6 out of 20, if we keep it and we don't put it back in, well, now there are only 19 marbles in the bag. 9 of them are still green. So the top number stays the same. But now on the bottom, instead of 20 times 20, we have 20 times 19. And we get 380. So 54 divided by 380. You could leave your answer just like that. You can make it a decimal, 0.142. I'm just going to round to the same as up above, and 14.2%. Of 100 students surveyed, 92 own either a car or a computer. Also, 65 own cars and 82 own computers. What is the probability that a randomly selected student owns both a car and a computer? So we have a little formula that hopefully you remember. The probability of A or B is the probability of A plus the probability of B minus the probability of both A and B. So the 92 is the OR. So the 92 goes here. A, I'm going to call the cars. B, I'll call the computers. Minus how many own both a car and a computer? Well, that part we don't know, so I'm going to subtract it. So right now we've got 92 equals 65 plus 82 minus x. I'm going to add the 65 and the 82, and we get 92 equals 147 minus x. So we get x equals 55. And then what is the probability out of 100 students? Question 5. A jury pool has 12 men and 18 women. 12 people will be chosen to be on the jury for a trial. Find the probability that there are exactly 3 men and 9 women on the jury. So it does not matter what order we choose the candidates in. So exactly 3 men and 9 women will look like that. So we're going to multiply those together to get how many different ways we could pick 12 men and 9 women, or sorry, 3 men and 9 women. And it is a big number. So 10,696,400 over, the bottom is the total, but choose 12. So 30C12. And 8, 6, 4, 9, 3, 2, 2, 5. And we get 0.124 or 12.4%. All right. A jury pool has 12 men and 18 women, same setup as from before. 12 people will be chosen to be on the jury for a trial. Find the probability that there is at least 1 man on the jury. So at least 1 means 1 or more. So this would include the majority of the possible combinations. It is very unlikely that there are no men on the jury. So I'm going to find the probability that there are no men on the jury, because it's a little bit easier to do that and work backwards than to think of all the 1 man and 2 men and 3 men and 4 men. That's a lot of work. So for there to be no men on the jury, that means there would be 12 women. So of the 18 total women, we're picking 12, and of the 30 total people, we're picking 12. So the probability that there are no men on the jury and I'm just going to divide these right away. Is tiny. 0.000215. So now, this is the probability there are no men. So over here, I'm going to take 1 minus the complement, the fact that there are no men. And there is a 99.97% chance that there will be at least 1 man on the jury. All right, next page. So the runs scored in 20 regular season games for Park Center baseball team are given below. Find the measures of central tendency and measures of dispersion. All right, so this one is a big calculator one. So we are going to need to go to our calculator, and we're going to start by hitting stat, enter, enter. So stat, enter, I guess just 1 enter. And then we should have the lists. To clear a list, I'm just going to slide this down so I can make some notes up above here. So clear the list. Go up and highlight the list name. And then hit clear, enter. Then the list should be cleared out. Now, enter the list below. All right, enter the list of numbers down below here. All right, so I have them all entered. I'm just going to double check that I didn't miss any. All right, looks good. So now what we do is we hit stat again, then go over to calc, and then the very first one. So it's that one variable stats, and then make sure it says list 1 or whatever list you put the numbers in, and then go down to calculate. And a lot of this stuff should come up. So this first one, the X bar, this is the mean, and I got 3.25. The median is a ways down, and that I got 2.5. The mode will not be in the list. The mode you will have to figure out by looking at the numbers here. So it does help to put them in order, as I'm looking, ooh, that's really big. And that's really small. So I'm seeing a lot of 2s. We've got 5 2s. We've only got 3 1s. We've got 3 3s. We've got 3 6s. Yeah, I think the 2s take it. So mode is 2. Q1 and Q3 are in your calculator again, and they're listed just like that. Sigma, this thing is the standard deviation. And this is 2.43. You can round a little bit there. The range is the biggest minus the smallest. So 9 minus 0 is 9. The IQR is Q3 minus Q1. So 3.5 minus 1.5 is 2. So the IQR is 2. If the team scored 1 more run every game next year, what would the new mean and standard deviation be? So the new mean would be 1 more, because every single one went up by 1. Mean. So it would be 4.25. The new standard deviation would be the same, because if they all went up by 1 run, they're just as spread out as they were this year. So standard deviation measures the spread. And so if all the numbers move around by the same amount, their spread doesn't change. The team expects to score twice as many runs next year. What will the mean and standard deviation of the runs be next year? So when it goes up by a multiplication factor, it multiplies by 2. So the mean would be 3.25 times 2, so 6.5. The standard deviation would also double, because the spread is twice as far. So the games where they scored 0 points, well, if you double 0, it's still 0. But the game where they scored 9 points, well, if they double that and they score 18, now the range is a lot bigger. The spread of the different games is a lot bigger. So this also times by 2. So 4.85. A standardized test is normally distributed with a mean score of 145 and a standard deviation of 12. Label the normal distribution curve. So remember, on these ones, the mean goes in the middle. I'm actually going to zoom in on this one. And then we just go up by 12 as we go up to the right, and we go down by 12 as we go down to the left. So 145 plus 12, we get 157, 169, and 181. And then minus 12, we get 133, 121, and 109. What is the probability a test score is between 133 and 169? Well, here's our 133, and then up to 169. So that is this region of the graph. So we would just add up this number and this number and this number, because those are the 3 columns that they cover. So 34 plus 34 plus 13.5. So those numbers always stay the same. They don't change with different examples. The percents in each column are always constant. Those are the numbers. On the test, those numbers will either be there or I have no problem putting that on the board. I do not expect you to memorize those. All right, so this is the first 2 pages. I'm going to make a separate video for the next 2 pages so it doesn't get too long. Good luck.